Hi, in this video we're going to continue our review of functions and continue with inverses, and this is going to be for trig functions. And so I might do a little bit of review of trig functions as we go through this. So let f of x be sine x is the function 1 to 1. So what do we think? We should probably, in order to answer this question, probably look at the graph. What does the graph of sine x look like? So I have one period of sine x here. And notice right away that in order to be 1 to 1, we say every output, so every y value has exactly one input, one x value. Or it passes the horizontal line test if you have the graph available. And in this case, if you start drawing horizontal lines, notice that this does definitely not pass the horizontal line test. So this is not 1 to 1 in its domain. So that means that it doesn't have an inverse, at least not in this domain, right, from 0 to 2 pi. So my second question is then what does it mean to find sine inverse of root 3 over 2? You see the inverse trig functions on your calculators. You took trig and pre-calculus, and so we've found these values. So what does it mean to do that? Well, it does have an inverse, right? We just have to, as we did in the prior video with the functions there, restrict the domain. So we want to restrict the domain of sine x so that it is 1 to 1. So let me do the graph again over here, and let's restrict the domain. We want it to be 1 to 1. Now, looking at this portion of the graph, it might be easier to think, well, if I just do from 0 to pi over 2, I don't quite get a full half of the period, right? Or even, well, I know that a full period is not 1 to 1, so I want at least half the period. But if I take from 0 to pi, that's still not 1 to 1. I can't just take 0 to pi over 2 because that's not half the period. And same thing here, if I go from pi to 2 pi, that's not 1 to 1. So I could go from pi to 2 pi, and that would be 1 to 1. But we don't like that. Any guesses why mathematicians may not like that? You can pause the video and think about it or answer in your head real quick. The reason we don't like that is because it doesn't include 0. We really want to include 0 when we do inverses, when we do any functions. So what we're going to do instead is we're going to extend this graph to its other side. So I'm going to try to just freehand it here, so bear with me. So this will go to negative pi over 2, right? So now from negative pi over 2 to pi over 2, so if I take this portion of sine x, now if I do my horizontal line test on that region, on that portion, now it is 1 to 1. So I have a nice portion of sine that allows me to be 1 to 1, and it includes 0. So 1 to 1 on, we're going to say negative pi over 2 to positive pi over 2. So we are 1 to 1 there. So that means that f of x equals sine x has an inverse on that interval. And so notice that if you do sine inverse of any number, your answers are always between negative pi over 2 and pi over 2. And so that's the reason, is because of the domain restriction for these functions. So let me show you what I mean by finding sine inverse of two different things. So the difference really lies in how the question is asked. So for example, if I ask you to find sine inverse of the square root of 3 over 2, then this is using the sine inverse function. And so I would need to find, what does this mean, right? So this is the sine inverse is giving you an angle. Right? Essentially, when we take our y values, right? The square root of 3 over 2 is our y value, so it's asking you for what value, what angle corresponds to that y value. So when I'm asking this, is sine inverse of root 3 over 2 is going to be some angle, let's call it theta. This means that sine of theta is the square root of 3 over 2. So that might be easier for you to think about, like, oh, because now you can use your unit circle or you can use any of the tools you use in trig or pre-calculus to find these values. So for me, one of the things that I tend to use is this little table. I learned it when I was in calculus myself, actually in pre-calculus, and so I always use it. And I'll simplify it. I'll do the long version of the table and then I'll simplify it. So I always think of the angles, your reference angles. Oops, that's not what I want. Hang on. This is what I want. I want a circle. So I want my unit circle. So reference angles are the ones that are on the first quadrant. So you have 0, you have your pi over 6, your pi over 4, pi over 3, and then pi over 2, right? So these are your reference angles. And so those of you that choose to remember the unit circle, then that's how you will find your values. Now for me, I like to use this, and so I'm going to go with 0 first, then pi over 6, then pi over 4, then pi over 3, and then pi over 2. So I just list my reference angles in the order from 0 to pi over 2. And I know the sine of 0 is 0. And so I go then from here. So I'll show you what I mean by this. So then I'm going to go 1, 2, 3, 4. And then for cosine, I just reverse that. 4, 3, 2, 1, 0. Now let me explain what I'm doing here. So my table, what I actually remember, and usually when I used to take quizzes or tests, I will write this, what I'm about to write here. This is what I will write on the top of my paper. So theta, sine, cosine, and I will go 0, 6, 4, 3, 2. And so except for 0, right, these are all pi over, pi over, pi over, pi over. So that gives me my angles. And then on the table, all of these are the square root over 2, the square root of over 2, the square root over 2, square root over 2. So if I want the sine of pi over 2, the square root of 4 is 2 over 2, that's 1. If I want the sine of pi over 6, that's the square root of 1, which is 1, so 1/2. And the same thing over here. So cosine of pi over 4 is root 2 over 2. But this kind of gives me a shortcut to finding these. And so I always write sine first because sine of 0 is 0. So I know that 0 will have 0 on the bottom, and that's sine. Sine of 0 is 0, and then I go right 1, 2, 3, 4. And for cosine, I just reverse it. 4, 3, 2, 1, 0. So cosine of pi over 2 is 0. Cosine of pi over 6 is root 3 over 2. So that's how I remember it. So as you continue to watch videos from me throughout this class, sometimes you'll see me write that table somewhere along in the video when we're doing trig problems, because that's how I remember my values. That's what helps me find my values. It's a tool, you're welcome to use it. That just means you have to remember this method. Whatever you use already, if you use the unit circle or if you use your triangles, right, 45, 45, 90, or 30, 60, 90, that works. You don't have to learn this, right? If this is something new and you already have a method that works for you, do what works for you. But if you don't have something currently that helps you remember your trig values, I'm just trying to give you something, another tool that might work for you. All right, so then back to this problem. Sine of theta is root 3 over 2. So what angle gives me the sine is root 3 over 2? So it works backwards, right? So sine root 3 over 2, so that will be pi over 3. So that means that then theta is pi over 3. And so that means that sine inverse of root 3 over 2 is pi over 3. Now let's use this to, let's try a different example. What if I want you to find sine inverse of negative 1/2? Now, sine inverse of negative 1/2, that will be based on the fact that sine is 1 to 1 between negative pi over 2 and pi over 2. So that means that when I'm looking for the angle that gives me negative 1/2, I'm going to be over here. So it should be a negative angle. And if you put that in your calculator, you should get a negative angle as well. And so this is going to be, let me look at this. So my reference angle, sine 1/2 will be pi over 6 as my reference angle, but I need it to be in quadrant 4, right? I need it to be a negative angle, so it's just going to be negative pi over 6. And that will be done. So that's how you do these. Now, there's a difference versus asking you find x and you have 2 sine x equals negative 1. Right, when you're solving an equation, this is a little different because now you will have sine x equals negative 1/2. So there's a difference, right, in these two. This is asking you, is using the inverse function. So when you're using sine inverse of negative 1/2, you're finding the angle within the restricted domain, within the sine inverse restriction. So that means that your values are going to be between negative pi over 2 and pi over 2. And that's it. When you're solving a trig equation, then all the angles are available. So you look at, okay, so sine x, and if I look at my circle here, where is sine negative? Sine is negative in, what is it? All students take calculus. So sine is negative in quadrant 2 and in quadrant, oops, that's where sine is positive, sorry. This tells you where things are positive. So all are positive, sine is positive, tangent is positive, cosine is positive. So that means that sine is negative in quadrant 3 and in quadrant 4. So when I look at something like this is going to be, I'm going to have two angles. So I'm going to have an angle in quadrant 3 and an angle in quadrant 4. And oftentimes you might see things like between 0 and 2 pi. So if you see that, then that means you're between 0 and 2 pi. My reference angle is still pi over 6, but now I need to find it in quadrant 3 and in quadrant 4. So pi over 6 is my reference angle. What do I mean by that? 1/2 is the sine value for pi over 6. And so that means that as I move along the circle, all the pi over 6's are going to have a 1/2. It's just positive or negative. So here, 5 pi over 6 is going to give me, sine of pi over 6 will be 1/2 as well. And then in quadrant 3, it will be 7 pi over 6. And that will give me a negative 1/2. So x will be 7 pi over 6, or, and then the one in quadrant 4, 11 pi over 6. So notice the difference in the answers, right? When you're solving an equation, you're not using inverse functions. You're using your knowledge of trig, your quadrants and reference angles. When you're specifically asked to find sine inverse, now you're using the inverse function itself, and you have to keep in mind the restricted domain. So sine inverse of something is only going to give you an answer between negative pi over 2 and pi over 2. Whereas solving an equation on a specified interval, you have to give your answers on that interval. Now, if you make the, I don't want to necessarily say mistake, but if you say x equals sine inverse of negative 1/2, right, then this will be negative pi over 6. But the question was asking you to give your answers between 0 and 2 pi. So you can still use this, but now you have to say like, oh, okay, negative pi over 6, but that's not on the interval. So you have to still go back and do this process of what is my angle in quadrant 3 and in quadrant 4 that are corresponding to negative pi over 6, right? So that may have been a long explanation, especially if you already know and are pretty familiar with your trig. So I'll try to note the time and then make a comment. If you're pretty familiar with your trig, you can jump to whatever time in the video. All right, so what about cosine of x? What's the restriction in the domain for cosine? Now, cosine x is also not one-to-one, and you can tell here that if you try to use the horizontal line test, it is not going to be one-to-one. So we want to be able to restrict the domain. And just like we did with sine, we want to make sure that 0 is part of our domain restriction. And cosine is a little bit nicer because it already starts at 0 for a period. So it goes from 0 to pi. So if I take this portion, now this is going to pass the horizontal line test. So that means that cosine of x has an inverse on the interval 0 to pi. So that's where it's one-to-one. And so again, if you're looking on your calculator and you're trying to find cosine inverse of 1/2, this is going to give you something in the first quadrant, and we can go back and use that table, right? 1/2, so cosine, so 1/2 will be this one, right? The square root of 1 over 2, so it'll be pi over 3. So your calculator should be able to give you pi over 3. If you have it in degree modes, then it will give you 60 degrees. Try to work in radians though, because then if you don't have your calculator in your scientific calculator in radian mode, we're going to run into problems as we get into chapter 3 and chapter 4. All right, so then that will be our cosine inverse. And so just as before, right now, if I wanted, what about cosine inverse of negative 1/2? Well, this is going to be, I already know my reference angle is pi over 3, so I just need to be in quadrant 2 because it is from 0 to pi. So that will be 2 pi over 3. Okay, so then those are our inverses. And your book has a really good graph on the inverses, so you can see it's better. You can graph an inverse by reflecting it along the line y equals x. So if you try to reflect this graph along y equals x, you will get the graph of cosine inverse. And notice that pi is, what's pi? The approximation is 3.14, right? So if I wanted to reflect this point, pi negative 1, along this, it will end up being over here. So, right, my x, remember for inverses, so if your f takes x to y, then f inverse takes y to x. So for f here being cosine, right, it takes pi to negative 1. So f inverse, cosine inverse, will take negative 1 to pi. So it'll be up here somewhere. So that's how I would reflect those. And so if you do that for every one of these points and reflect the line along the line y equals x, right, you're interchanging your x's and your y's, you're going to end up with this beautiful graph. So the black curve here is your f inverse of x, which is cosine inverse. And the red one over here is your original cosine x. So notice that here's the point that I was talking about. That's pi negative 1 in cosine x. So the inverse becomes negative 1 pi. So this is what the graph of cosine inverse looks like. So the domain of your inverse, the only things that you can put in for cosine inverse are values that are between negative 1 and 1. right? So your domain for cosine inverse of x is included, sorry, -1, 2, 1. And the range, which are the things that you get out of, are your angles from 0 to pi. So the range, remember we talked about the range of the inverse is the domain of the original. So we restricted cosine of x to be from 0 to pi so that we could have it be 1 to 1 and be able to find an inverse. So that domain becomes the range of the inverse. And same for sine x. So your textbook has the graph for sine x. And tangent x, we do the same thing. And tangent x actually is kind of nice because we already have one period. The period of tangent x is -pi/2 to pi/2 anyway. Oh, and by the way, to find values of tangent, we can use the same chart, right? Tangent is sine over cosine, so you can just, if I wanted to find tangent of pi/3, is √3/2 divided by 1/2, and I have my tangent. Speaking of tangent, let's do a couple of examples of finding some things that you might see in your homework or things that pop up. So if I want to say, for example, find tangent of sine inverse of 3/5. How do we find that? Now this is quite different than if I had asked something like find tangent of sine inverse of 1/2, right? 1/2 is something that we know. So let's go to the table. Which one gives me a sine of 1/2? So that'll be pi/6. So this is, when it's a reference angle, the math becomes a little nicer. So here I'm asking you for, right, that is the angle. What angle has a sine of 1/2? The angle that gives us a sine of 1/2 is pi/6. And so now I'm looking at like, oh, now I need to find tangent of pi/6. Well, pi/6 tangent is sine over cosine, so it will be 1/2 divided by cosine of pi/6, which is √3/2. So it will be 1/√3. And that will be tangent of pi/6. Now, with this is a little different because 3/5 is not a value from a reference angle. Now, what this means, this still means I want the angle, right? So this is still an angle. So I want tangent of the angle whose sine is 3/5. So let me write that down over here. So sine inverse of 3/5 gives us an angle. So this means that sine of theta is 3/5, right? The angle whose sine of that angle is 3/5. And from here, what we'll want to do is draw a triangle. We'll go back to basics here, right? How do you find trig functions? Draw a triangle and use the standard definition. What I mean by back to basics is sine is opposite over hypotenuse. So if I put theta here, sine is opposite, which is 3, and hypotenuse is 5. Now, depending how well you know your right triangles, you might be able to tell right away this is a 3, 4, 5 triangle. If you don't know your right triangles or you don't remember, it's been a while, just use Pythagorean theorem. I know a squared plus b squared equals c squared. So I'm going to have, I don't know, if I don't know what that is, let me call it b. So I'm going to have a squared, so 3 squared plus b squared equals 5 squared. So 9 plus b squared equals 25. So I have b squared is 16. So b is plus or minus 4. I am dealing with the triangle, the length of a triangle, so I only take the positive. So b is 4. All right, so now that I have my triangle, I know I have my completed triangle, so now I can find tangent. So tangent of sine inverse of 3/5 means really tangent of theta, right? This theta, the angle whose sine is 3/5. So that's what sine inverse tells me is the angle whose sine is 3/5. That allowed me to draw that triangle, and now I can use the triangle to find tangent of that angle. And so tangent of that angle, tangent is what? Opposite over adjacent. So this will be opposite is 3, adjacent is 4. And so my problem is done. So I'll leave you with, for the end of this video, something to try on your own. So I want you to find cosine of inverse tangent of root 7 over 5. So again, this is not a reference angle, so my hint is draw a triangle. All right, so try that, and if you want to know what the answer is, send me an email or write it in your notes, and I can then, when I grade the notes, I can look at them, at your answer.